So one of the things I'm looking at, I was just, we're talking to this guy, Reginaldo Hazlitt-Marroquin. If people haven't seen what he's doing with poultry, it's quite dazzling. He's calling it tree range poultry. It's poultry-centered regenerative agroforestry. We'll be definitely working with him. And that's the way to design it. But if you have so I was just recently in Iowa on some poultry farms. I visited this, what I think is a next level biochar low pressure boiler system that has the capacity to do all the things that we're interested in with green wood instead of dry. So it was fascinating because I went to and visited this place and they said, well, you should go check this guy up in Iowa out. And I was on my way to Colorado. I was in Missouri. And I went to Colorado and I was doing organic inspections in Missouri on the way out and Iowa on the way back. So I didn't even look at my files, but the guy that he told me to go visit was happened to be one of the 6 files I was already going to do. So I went there and he had one of these unimpressive poultry operations where you've got 8 to 25,000 birds in one huge house with pastures. I mean, it's organic, but it's a bit embarrassing there's certain holes in the organic system. For the most part, it's been way better than most people give it the rap. But poultry needs work. Hogs need work. There's a whole bunch of things that need work. But anyway, so the thing that happens in these poultry houses, if you're going to retrofit something and you're going to try to make best with what you have, is this whole conversation of when do you just bail? When do you just tear it down and redesign it? Or use the infrastructure for something else, repurpose it or whatever. Anyway, without getting into that conversation, this guy was using biochar from the place that I visited because what happens in these poultry houses is that the ammonia levels go up. They have sensors and the ammonia levels go up and it triggers, flips on opens the vents and turns on the fans and then if it's 55 degrees or colder outside, it turns on propane heaters to keep the birds at the temperature that they want them for laying eggs, in this case. So if you put biochar in there, they tried to use it in the bedding, which would have been good, but the egg buyer didn't like the black marks on the eggs, right? But so what he had was a negative pressure air circulation system in it. He was pulling the air from the top down through the floor, through the biochar that he put under the floor. So he was able to absorb the ammonia, capture the nitrogen, and for the soil, instead of blowing it out as an air pollutant, saves the electricity from the fans, saves the propane for the heaters. And so then I started asking, well, how much are you paying for that walk-in cooler a year to keep the eggs cold? And how much are you paying for the propane to heat the house? And so if you had one of these low-pressure boiler systems where you're making the biochar there instead of trucking it from Missouri, the economics start looking really interesting. And then even more so if you've got nut trees out in your pasture and you're starting to do what Reginaldo's up to, which is a huge ball of wax and fascinating. So this is just showing some different types of livestock integrated into agroforestry systems, and you can do all kinds of variations in this with crops in between here and cover crops and whatnot and grazing cover crops. The territory is pretty broad. So in the thinned forest model that I mentioned, I mentioned I'm starting to do the forest grown medicinals certification. This is Goldenseal. We have a proposed grant with the United Plant Savers. I've been seeing such dazzling changes just with the volcanic minerals that I'm really curious to see what will happen if we use some biology and some volcanic minerals on some test plots and then look at the, take your seed pieces, cut them up into uniform pieces, and then measure the alkaloids in them. And before long, we should be able to calibrate the handheld spectrometer to do that. You could also do it for CBD and maybe be selecting for seed stock in fields and hundreds of other things with this, where this is going with milk and meat and so forth, even soil carbon. But what I want to do is just to see, do we get a bump in alkaloids? And Goldenseal is relatively simple compared to ginseng. There's like 20 ginsenosides in ginseng, and there's berberine and forgetting the other alkaloid right now, hydrastine. And so does the chemistry change and does the yields change? Because the herb people would be, completely ecstatic about either one, but just a yield increase would be interesting to them. So lots of potential to just go into these innovation systems, but this forest is going to be way less prone to burn, and the soil moisture is going to be higher, and that's not super interesting as a ground cover as one species, but this could be done in lots of other ways with the cohoshes and tons of other medicinal plants and mushrooms and maple syrup and all of the above. So yeah, ginseng. There's a whole supply chain problem with ginseng and what is being proposed, and I'm pretty sure that PCO has dropped the shade-grown or forest-grown ginseng certification, but I think that UPS, United Plant Savers, is going to pick it up. Since I'm already working with them, I'll probably keep tweaking it so that the biodiversity index is better. Lots of potential for these medicinals. I mean, there's no shortage of people that need assistance. I mean, I give a talk down at the United Plant Savers Sanctuary every year with the new interns that keep coming through, and the first question I ask them is, because they're all there to study medicinal plants. The first question is, what's a medicinal plant? And they kind of know right away it's a trick question, but it's, so basically I say, well, if you were to feed the whole nation very nutrient-dense food in abundance, and you got a 50% drop in symptomologies of all the different medical problems, would that food be medicine? And then if we were to, rehydrate these, all these landscapes and maybe not go extinct, would that be medicine? But these are very powerful forest medicinals here. I mean, incredible. I don't know how many people use them, but they're amazing for immune system and anti-cancer and numerous other things. Underutilized, but getting a lot more popular now. You can actually get a lot of the chemistry just from growing the mycelium into a grain mix, not the chaga, but all the other ones. I've got a friend who's making a 14 mushroom powder that's really powerful medicinal product because it's got 14 different medicinal, all of these and more, except for the chaga. He adds the chaga separately because you can't grow that on grain. Lots of, temperate zone analogs to the tropical stuff we looked at. So we talked a little bit about exudates and the increase of exudates in healthy plants. And so, this is really amazing. If you haven't looked at the work of Christine Jones, she, the problem with this reductionistic science is that, up until her work, as far as I know, the studies that were done were looking at plants in sterile mediums in pots and measuring exudates from that and getting really different kinds of results than what you would see in say, a forest plant like those, or really rock and vegetable or grain plant with after cover crops and all the bells and whistles that we're playing around with. But this is a very powerful soil building piece of the puzzle, and so the importance of having exudates year-round is really a big deal, because you build up all these microbial populations and then all of a sudden you knock them down and there's nothing there for a period. All those microbes got to eat something, and they start, it's like an autoimmune disease, they start digesting everything that you've just built up. So this plant, this is a Mycorrhizae colonized, and this is on, you can see this one's in full communication with the A, B, and C horizons of the soil, and has access to all kinds of things that are there. And Mycorrhizae is sort of like the ultimate biological internet, and there's just tremendous amounts of complexity and communication going on, and adaptation, access to water and minerals. bacteria are riding on the front end of some of these hyphae and literally being used as miners to mine rock nutrients and then giving that back to the plant, and the plant is sharing sugars. So that's this ancient collaboration between fungi and photosynthetic algae and plants. Our gut has similar connectivities. I started off in the beginning talking about the vagus nerve and what's happening. There's you hear language in the research that the bacteria there's crosstalk between. I'm not sure exactly what that means, but crosstalk between our gut microbes and our mitochondria, and crosstalk between our gut microbes and the soil microbes. And I don't know if I mentioned it, but Walter had mentioned that the bacteria that's involved in, I think they classified the bacteria from Aerobacter to a different bacteria that's involved in nucleating hazes is related to our gut bacteria. So we're like super interconnected in ways that are, we'll just find out more and more and more as we go forward, but absolutely fascinating. And so the mycorrhizae is kind of, in a way, the end game where we're headed with regenerative agriculture. If you can we're even talking about, one of the things that Walter mentioned was, in a conversation I had with him about what do we measure with this infrared tool that we've got? Do we mess around with the actual specific nutrients, or we just go straight to say, is there some signal that this plant, if you pull a root out and test it, that it's colonized with mycorrhizae? If it's got mycorrhizae, it's got access to everything. So it's going to be, that was just a thought. But I think that there's a lot of cases where we need to know specific compounds. And that carrot with the polyphenols 200 times, those are things that people are buying in supplement bottles for quite a bit of money. And if you can see that, wow, this farmer's got carrots that I don't have to buy those supplements if I eat those. So you can't just go to your doctor and say, what should I eat at all? It's a whole different world. So back to strategies of building soil rapidly. People are probably familiar with keyline. This is something that came out of Australia, and it's basically a deep ripping technique that is opening up the soil, particularly a little bit into the subsoil each time, and accessing water, oxygen, and temperature, and creating a zone, a bacterial and microbial life zone that would otherwise be too not accessing enough of any of those three, and getting to, some people are claiming pretty big results, like 5 inches to 18 inches of topsoil in something like 5 years. So this can be done in some interesting ways in terms of swales and tree plantings, and essentially capturing that water that would be running off. So intervening on those soils that would have been flooding. And so what happens here is that the water on a first rain, you're going to watch it, and it's going to want to run right down here and right down there. And so instead of letting it do that, you're catching it way up here, and you're filling up these trenches, and it's running out to the dry ridges where it wouldn't be much at all. And then the trees and the whole package. The things that you grow in between here, and you can integrate a lot of these tools. These are just building a tool set for what can be done on any particular land. This is pretty intensive in terms of energy and machinery, but if you're drying up and you're going to zero production, it starts looking like a possibility. In some places, it's much more relevant than others. You can, I believe, let's see, there's a guy in Sweden that's basically making similar things to this, except without really tearing up the ground very much, and getting some pretty interesting results. So just going through some of the possibilities. So what I was saying about, so the first year, the rip would go just 1 inch into the subsoil, and then the second year a little deeper, and each year you're colonizing more root activity, rootability, as they say.
So Mark,
yeah,
we just got a keyline plot. We But I sit there looking at it, thinking about how expensive they are. You need a pretty strong tractor to pull them and all that. What do you think you can do with plants instead? Can you get similar results with deep rooting, powerful plants? I mean, I think it will seed radish, but also other plants that are noted for having really powerful root systems.
Definitely. Part of it is like, how much time do you have? You know, it's a little bit like, Elaine Ingham is saying, you don't need any of these inputs, but, she's not a farmer. And for farmers that need to have some turnaround and get a quick result without it being a chemical result that's going to actually build microbial life, part of this is like, how much time do you have? Like, do you need to have it?
Farmers, it's how much time and how much money.
Right. That's what I mean. That's actually what I mean by how much time.
But see, for a lot of small farmers, they can't afford the equipment until we can get ways to get it to.
Yeah. Well, that points to the whole cooperative story,
right.
and basically sharing tools, and because those are exactly the kind of tools that make huge sense to share in a region. I mean, soil and water folks have no-till planters and things like that. They would be a sensible place to have to get them to buy those. And then,
I couldn't agree more. We need to be lobbying for these kind of tools.
Yeah. Mm-hmm. I'm just running through some of the things that are options, not necessarily advocating how to do it on a particular farm. I think that you have to look at each place. I mentioned the guy in Sweden that's doing a similar pattern without necessarily building such deep swales and so forth. But I think he might be doing the ripping. Not sure why I'm not moving here. Okay. So yeah, lots of interesting landscape stuff. So part of the keyline stuff isn't just ripping and swales. It's creating a lot of lakes, catchments up high in the landscape, and then in the parts of Australia that it came out of, that they had a 3-month period when it's so dry that they save the water just for that 3 months, and then they can release that water back into those swales and saturate the ground at the time when they really need it. So it's not just about keyline plows. It's a whole comprehensive system. So I talked about distributed systems. This is a pretty nice example, I think, of distributed systems where all these farms have, these are smallholders. I think smallholder farms around the world are producing about 70% of the world's food supply on about 25% of the agricultural land. So this whole agribusiness thing is way overrated. It's producing inferior food. It's not nearly as important as they're making it out to be. So that's emulating kind of what we can look at here, is have a lot more people farming smaller scale, and storing things and creating resilience. What I see is in where I live, which is supposed to be like the mecca for local food in Ohio. You watch the news and there's a storm coming in, and first night everybody strips off the food off the shelves in the store, and everybody's running around buying food that's traveling all over the place with all packaged and whatnot. And that model, that Amish model I mentioned, they just stay home and they've got half a year of food supply on every farm. And they're not even using electricity, so they don't have to do that. But and they've got animals that are, all their work's coming out of animals as long as their pasture's growing. And so you can sort of play out some of these scenarios of what happens when these, more intense floods and fires and droughts happen. What's the strategy? So we really need to look at, people that have been around a lot longer, number one. They've been through a lot of this before, and their traditional ways of life and traditional environmental knowledge is really like gold. And unfortunately, a lot of places are like one generation away from nobody remembering how to do things anymore. So a lot of this cultural knowledge is just as rare as the species that we're losing.